Jupiter and Saturn. Huge, huge planets. Earth would be like yay big. Earth would be like yay big. These guys are huge, but they're mostly gas. Let's talk about Jupiter first. More pretty pictures of Jupiter. This is how Galileo might have seen it back in the day when he first looked at Jupiter through his telescope and saw the four Galilean moons and shook the whole world. A better picture of Jupiter with all the bands, zones, and belts, and the big, big storm here. And even more detail for the zones. You can start to see little. What this reminds me of, if you ever made coffee and poured cream in, uh, just before you stir it, the cream kind of like makes a certain pattern. And to me, it looks a lot like these cloud patterns here. Another nice picture, the great red spot here, and the little wispies leading up to it. Jupiter. Jupiter is huge. It's 318 Earth masses. So you pick your mass, picture your mass, which is whatever it is, right? And picture 318 of you. That's the size difference. You could fit a little more than 11 Earths across Jupiter, or if you think of like a gumball machine, you could fit 1,400 Earths inside Jupiter. Huge. Jupiter rotates differently than the inner planets, the terrestrial rocky planets. It rotates more like a star, actually. They call it differential rotation, where at the equator it rotates more quickly than higher up towards the poles. In fact, 5 minutes quickly. It has a very short rotation period. Earth's day is about 24 hours. Jupiter is less than 10 hours. So, and just like if you spin a pizza dough, it'll flatten out. So will Jupiter. But it doesn't flatten out completely because it most likely has some sort of rocky core inside. If it were all gas, it would be flatter, but that's not quite the case. And you can see here, with that rotation, you get gravity pulling equally from all directions, and you get a nice spherical circular shape. But with this rotation, you get a outward quote-unquote push. It's not a real force, but it's kind of an inertia thing. And gravity is doing all it can to keep this stuff from flying out into space. So Jupiter, being made up of a lot of gas, has an interesting atmosphere. In its atmosphere, you can see the Great Red Spot, which is a hurricane-type storm. This storm is in size about 2 times as big as our entire planet. And Galileo saw it back in the day, so it's been going strong for at least 300 years. And much unlike Earth and the other terrestrial planets, its atmosphere is mostly composed of the lightest element, hydrogen, 86%, and then the second lightest element, helium. So these gases are light, and you need a strong gravity to hold them in. The Earth can't really hold a lot of this gas in because it's so light that it'll easily escape our meager gravitational pull. The Great Red Spot. One Earth, two Earths. Little Maryland here. Huge. There's another little storm right next to it. A little bit smaller. You can see the different colors. We're going to talk about that in a sec. So you probably also notice that Jupiter has bands and atmospheric bands. What's going on there is we got convection, cool material sinking, warm material rising, convection current, and this drives the bands around. And they have different colors depending on whether they're lower or higher, what type of material they're made out of. I just said that the banding is caused by convection. Zones are the name for the lighter bands, and belts are the name for the darker bands. So belt zone. And these zones are denoted by the different rotations. Here you see zero velocity, meaning it's not rotating relative to the planet essentially. And if you look here, this is negative velocity, which means it's actually going that way, relative, and over here our positive velocity is going that way. So the farther away you get from this vertical line, the faster you're moving relative, and also depending on the side, you get a certain direction of flow. These zones act like jet streams on the Earth, much more complicated than the Earth. The Earth, while it is pretty complicated because we can only, predict, and not always that well, just a few days in the future, uh, Jupiter is way more complicated. The atmospheric structure. So if you were to take a cross section, if you were to be able to kind of sink down into Jupiter with a little spaceship that could withstand huge amounts of pressure, you would go through, in this sense, a less complicated in terms of pressure, a less complicated system than the Earth. But you'd go through ammonia. Of course, you'll get the hydrogen and helium down here. I get some methane, ammonia, water, even like a layer of water ice down there. But it doesn't get hot until you get closer down to the surface. So we have these cyclonic storms on Jupiter, as I mentioned earlier. The biggest ones are the red ovals, like the Great Red Spot. The white ovals, which we saw just next to it, this one. These tend to be the medium-sized ones, and these little brown ovals here tend to be the smaller storms. So brown ovals are the small storms. I have another picture of a brown oval somewhere. There's one. And you can actually tell, if you were to watch a movie of this, you could actually tell the rotation rate. So if you have one band going this way and another band going this way, it would cause this storm to rotate around like that. Internal structure of Jupiter. So Jupiter, like we said, is made up of a lot of hydrogen, and of course, as you get closer to the center of Jupiter, the pressure there is extremely high. The gravitational pull is extremely high, so that hydrogen condenses into a liquid, which is not easy to do. And then once it's in liquid form, it behaves kind of like a metallic-like material. Now, there's most likely also some rocky elements down there early on, but it's not believed to be like a terrestrial planet because of the extreme atmospheric pressure and high gravity. And a cross-section of what the inside of Jupiter might look like. Here we got this purpley area is the metallic hydrogen. This might be the rocky core. And then up here you have the atmosphere that we can actually see. Jupiter also has a magnetic field, huge magnetosphere. Makes ours look like puny crap. And this is actually a dangerous area because it's there's lots of radiation going on here. Being near Jupiter is not a fun thing. Just like Jupiter is kind of like almost like a mini star in a sense. Not quite, because it's not fusing like a star, but it just a bit bigger and it would have started to become a star. So just like you don't want to get near the sun, you don't really want to get near Jupiter either. And you can see the solar wind pushes back the magnetic field. And you got this interesting thing, which we'll talk about, which forms from one of Jupiter's moons, Plasma Taurus, but we'll get to that in a bit. So Jupiter's magnetosphere, it's extremely large, and it comes about because of Jupiter's metallic-like hydrogen core, and Jupiter rotates really fast, just under 10 hours like we discussed earlier, so that will make for a big magnetic field. Van Allen belts, just like our Earth, but these belts are much stronger. And you can see here, I'm going to mention in another slide with the notes, but you can see the tail of this goes out and extends out to Saturn's orbit, really far away. Its magnetosphere is 1,000,000 times more voluminous, meaning like in terms of volume, than ours. Its tail extends 4 AU out into Saturn's orbit, and it produces auroras that are bigger than our entire planet in the poles, just like ours are produced. Jupiter has a lot of moons. Currently 67 moons, 4 of which are big, Io, Europa, Callisto, and Ganymede, and 63 which are not so big, mostly just like captured asteroids. You can see the 4 Galilean moons make nice kind of regular orbits, but the captured ones not quite so much. Here's a nice beautiful picture with Europa and Io and Jupiter in the background. It's pretty sweet. You can tell the sun's coming from this way because of the shadow in here and the side of Jupiter. Here's a picture of the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. They all have their own very special characteristics. Looking very different here. These are the 4 largest moons of Jupiter. Galileo discovered them a long time ago with his early telescope. And their orbits are quite circular. Of course, they're elliptical, just like all the planets and moons, but for the most part, they're pretty circular, and they lie pretty well along Jupiter's equatorial plane. If you were to draw an equator on Jupiter, they would follow that plane. Io, let's talk about Io first. It's a rough-looking moon here. It's actually a very active moon. It's the most geologically active body, excuse me, in the solar system. I'm going to pause for a sec. You didn't need to hear my coughing fit. Anyway, so Io is the most geologically active body in the solar system, and that's because it's being beat up. It has a few bullies around it. There's a part of this activity leads to volcanic activity, and on Io is a very large volcanic structure which we call Loki, and you see recent Avengers movie, which this volcano is pretty big. Not as big as Olympus Mons, but still pretty big, about as big as Maryland. What causes all this activity is a tug of war between Jupiter and Europa. So you got Jupiter on one side of Io and Europa on the other, and they're pulling on opposite sides, and this causes tidal friction inside Io in the core, which leads to a lot of heat and pressure that drive the high activity. Here you can see volcanoes on Io erupting. Close up of that. Volcanic activity here. Some clouds going, volcanic clouds going up. And as I mentioned earlier, around Jupiter, there's this plasma torus. Where does that come from? Well, it comes from Io and the high activity. Io's eruptions and low surface gravity cause massive amounts of sulfur dioxide to be thrown into Io's orbit around Jupiter. So since it's a small moon, the gravity can't really hold down this gas that well, and it gets put into orbit. And this causes a belt to be formed around Jupiter, which has high radiation levels. You wouldn't want to be in this belt. It would not be fun. And we call this belt a plasma torus. Again, this is what it looks like. I think that's it, or maybe one more slide. Yeah, that's it. We'll start with Europa the next video. Alright, talk to you later.